So far in this module, we've discussed learning decision tree, but we only use what's called categorical data, inputs or features. So we looked at, credit could be poor, fair, or excellent. However, if you look at income, that's what's called a real value feature. It has continuous possible values, so 105,000, 73,000, 69,000, and so on. So the question is, how do you build a decision tree with this kind of input? One natural approach is to just treat income or the continuous value feature like we did with the categorical data. So let's take that root node with 40 data points and just split it on income and see what happens. Well, there is one data point with income of 30,000, there's one data point with income of 31,400, there's one data point with income of 39,500, and so on. And it turns out that the nodes that we get out of them basically only have one data point in them. And this can be really, really bad. When you have very few data points in an intermediate node in a decision tree, you're very prone to overfitting, very prone to make predictions you cannot trust. So for example, if you look here, you'd predict in this case that if your income is 30,000, this is definitely a risky loan. But if your income is 31,400, it's definitely a safe loan. However, if your income is now 39,500, you're back to risky. So it's risky, safe, risky, which doesn't make any sense. I mean, do you trust it? I wouldn't. And so the question is, how do we deal with these real valued features? As a very natural alternative, we can do work called threshold splits. And these are simply picking a threshold on the value of that continuous value feature. So let's say 60,000. And for the left side of that split, we put all the data points have income lower than 60,000. And on the right, we put all the data points have income higher than or equal to 60,000. And as we can see, we have a subset of the data here that has income higher than 60,000. And for those, we have many data points there. So it's a lot less risk of overfitting. And we see that 14 of them have are safe loans, so we probably predict a safe there, while 13 were risky with income that's 60,000, so maybe we predict those as risky. So this is a very natural kind of split that we might want to do with continuous value data. Let's now take a moment to visualize what happens when we do this kind of threshold split. So for example, I've laid out my data of income into this line here that ranges from 10,000 to 120. And if we pick a threshold split of 60,000 and we say everything on the left of that split has come less than 60,000, and we're going to predict them to be risky loans. Everything to the right has income higher than 60,000, we're going to predict those as being safe loans. Now let's suppose that we have two continuous valued features. We have income in the y-axis and we have age in the x-axis. And let's see what happens here. And you see there's some positive and negative examples laid out in 2D. And the other thing that's interesting is that you see that older people with higher incomes tend to be safe loans, but also younger people might have lower incomes, but those might also be safe loans because those people might make money over time, let's say. So we might look at this data and decide to split on age first. And if we split on age, let's say age equals 38, we'll see that for the folks that are younger than 38, on average, more of them have risky loans, so we might predict risky. But for the folks that have age greater than 38, we have more safe loans than risky, so we might predict safe. Now, if the next split in our decision tree, we might choose to split for the folks that have age greater than 38, we might split on the income and ask whether this income greater than 60,000 or not. And if it is, we put a split there, and we'll see that the points below, income below 60,000, even at a higher age, might be negative, so might be predicted negative. So let's take a moment to visualize the decision tree we've learned so far. So we start from the root node over here, and we made our first split, and for our first split, we decided to split on age, and the two possibilities we looked at were, is the age smaller than 38, or is the age greater than or equal to 38. So that was our first threshold split. And for those with age smaller than 38, let's say that we stopped right here, we'd see that there's 5 risky and 3 safe. So we'd predict risky. So that might be our leaf here. And for age greater than 38, we took another split, which was on income. And we just ask ourselves, is the income, is it less than 60,000 or is it greater than or equal to 60,000? And for the ones that have income greater or equal to 60,000 and age greater than 38, we predicted those were safe loans, while the ones that had age greater than 38 and income less than 60,000, we predicted those to be risky loans. And this is an example of a decision tree where we're making this binary splits on the data for the continuous variables.